Hey guys, Mr. Ray here. Hope you had a great long weekend. Ready for a nice week of weather and a couple of math lessons. Today is Tuesday, so a lesson today, and then another lesson on Thursday on Pythagorean theorem, and then an assignment, which will include similar triangles we did last week plus the two lessons this week. Okay. Don't forget, come for extra help Tuesdays and Thursdays. Uh, 11 to 1 on Tuesdays and 1 to 3 on Thursdays. You can always send me a remind message if you're getting stuck on a question. I can help you through that too. Okay. So today's lesson, we're going to take the similar triangles that we learned in last week's lesson. Remember, similar triangles are triangles that they don't have the same side lengths, but they have the same angles. That's not a very good triangle, but their shapes are similar. So for example, that these two triangles might be similar, these two angles are the same, and these two angles are the same, but maybe this triangle has all its side lengths maybe twice as big as these side lengths. Okay, so they're similar, and we're going to use the fact that some of the properties of similar triangles to help solve some problems. Okay, and they're actually kind of cool problems. If we don't do too many lessons in math outside, but the first question here would be one that we do. So um, let's just jump right into this question. We got three of them all together. Shouldn't be too long of a lesson. So this is a question you've got to, well, basically, you want to find the height of a tree, and the tree is too tall to climb, or you know, maybe you can't climb trees, maybe you can't figure out how tall it is, but we're going to use some properties of similar triangles to get that. So, and in this case, we're actually going to use the sun. The sun will cast shadows of objects. Okay, so you have something that's really tall, like the tree, and it casts a shadow down here. So the shadow from the tree is 15 meters long. You don't know how high it is, but you do know the length of the shadow. So, and then you do something smaller, like for example, maybe you have a 3 meter pole, and you stick it straight out of the ground, and it casts a 4 meter shadow. So we're going to first of all prove that these are similar triangles, and then we're going to use its properties to find what we're looking for is the height. So I'm going to call that h for height. And you can see already, that these two angles are the same. They're both 90 degrees. So in order to really start naming things, we're going to give the triangles names, or at least the points of the triangle. So we'll call it ABC, and we'll call this one DEF. Okay, so the very beginning, we know that angle B is equal to angle E, and they're both 90 degrees. That's given to us. Now the second one is the one that maybe you knew this, maybe you didn't, but the angle, because this is obviously not to scale. The sun is a lot farther away than that. So basically, any angle that the sun casts on the Earth will be the same angle. If you got two objects that are right beside each other, the angle here, angle A, is always going to be equal to angle D for the shadows. Okay, so that's the second set of angles we know is equal. Angle A is equal to angle D, and for a reason, I like you to show me why this is true. All you have to put is the word sun. Okay, the sun casts the shadow at the same angle. And then the good thing is, if we know that two pairs of angles are the same, which we now know, then the third pair, angle C and angle F, have to be the same because they add up to 180 degrees. Okay, so right there we've proved that these two triangles are similar. So we make a therefore statement, and the order we put these is important from last lesson. So I'm just going to call this triangle ABC. I can arbitrarily choose that, and that's similar to triangle. Now we have to put these letters in the right order. So A matches with D, so it goes first. B matches with E and C matches with F. Now, they happen to be alphabetical just because I happen to pick them in alphabetical order, but you can't just change the order around. You have to match up the angles to make that second triangle name. Okay, so now that we know that, we can start looking at the side ratios. Okay, now after a while, like when we were doing this in the first lesson, I always put the three ratios with two equal signs equal to each other. Well, we don't have to do that all the time. If you happen to know which two sides you're going to use, you can go ahead and just put them. If you're not sure, put all three, cross the one out you don't want, okay? Now I do happen to know that I want to figure out what H is, okay? So H, if we're just looking at the sides, H is AB. So what side does AB go with? AB goes with first, second, DE. So there's my first ratio. Now the second ratio can either be using this side or this side, and we know that we have to know the length of the side in order to use it here. So for the ABC triangle, the other side I'm going to use has to be BC. Okay, and what side does it go with? It goes with 2, 3, 2, 3, EF. Okay, so now it's just a matter of changing these side lengths into actual lengths. Okay, so AB, we don't know. That's what we're trying to find out. That's H. DE is 3 meters. BC is 15. And EF is 4. Okay, so if I want to get H by itself, I want to multiply both sides by 3. So H is equal to 15 over 4 times 3. And when I work that out, it works out to 11.25. And the units would be meters because all these other measurements were in meters. And then all word problems deserve a word answer. What is the height of the tree? Therefore, the tree is 11.25 meters tall. So that's kind of a cool question. And in a lot of math classes in the past, we've actually gone outside, measured things like the flagpole. Obviously, you can't measure up the flagpole, but you can see its shadow. You can measure the length of the shadow. Then you can maybe take a meter stick, put it straight up off the ground, right beside the tree. See how long its shadow is. You know the meter stick is a meter, and you can, through the ratios of the similar triangles, you can figure out the height of the flagpole. Okay, so this is a pretty standard question. So here is another question. This time we're not looking up in the air, we're looking like a length of along the ground. So so this blue thing here, the smudge, looks like an ink stain. It's a pond, okay? So we want to find the length of the pond. So basically from P to N, we want to figure out how long is that side? How long is that length? So the surveyor took some measurements, and this is kind of like a question we had before with the width of a river. This time it's just the width of a pond. So you can see some of the measurements, and you basically forming two triangles here. So in this triangle here, you've got two side lengths, you've got an angle, you've got the two 90-degree angles. Okay, so what do we do first? Well, we have to show that they're similar triangles. So we start listing angles that we know are the same or believe are the same. So the first thing we know, the 76-degree angles are the same. So I'm going to say angle L is equal to angle M, and that's because they told us they are 76. Angle P, see P is a common point for both triangles, and they're both 90-degree angles there. That was told to us. Now, again, the third angles, K and N, we have no way of measuring these. Well, we could measure this one, but that's in the water. We couldn't measure that. But because we've already got two pairs of angles that are the same, we know that the third pair have to be the same. So that means K has to be the same, has to be equal to angle N. And I'm just going to put 180 degrees here because the three angles have to add up to 180. Therefore, the third pair has to be equal. Okay. So from this, we know that. Now I'll just pick these. I'll name this KLP. That's in alphabetical order, but it doesn't have to be. You can choose any order you want, but then you have to match up the angles in the right spot here. So K is the same as N, so it goes first. L is the same as M, and P is the same as P. So there's our similar triangles. KLP, triangle KLP is similar to triangle NMP. And then do the same thing we did with the tree in the last exercise. So what length do we actually want to get here? Well, we want this side here. So it's a little hard to see here because of the blue, but I'm going to call that X. That's what we want to get. Okay. So I want that to be my first part of my ratio. I want that to go right here. So X is actually PN. Okay, so what side goes with PN? Well, PN happens to be over here. So, I mean, it doesn't really matter the order we work. So I'm going to go back here. PN is 3, third, and first. So third and first here is PK. So PK goes here. Now, the order of this doesn't matter. KP, side KP is the same as side PK is the same side as KP, and NP is the same as PN. So what matters is you have the right combination of letters here for the side. Now what we need is, so in this triangle here, I need to have the side that I know the length of, and that's the PM here. Okay, I'm going to put PM, or it could be MP again. Okay, now what goes with PM? So we got 3, 2. 3, 2 is PL. Okay, now that was all the hard work. Now we just have to fill in the information with what lengths are here. So PN, that happened to be X. That's what we're trying to find. PK, or KP, that's 12. PM, 5. These are all in meters, by the way. And then PL is 3. Now to get X by itself, I'm going to multiply both sides by 12. So X is equal to 12 times 5 over 3. And that is 60 over 3 is 20. And the units are meters. So therefore, the length of the pond is 20 meters. And that's pretty cool. I mean, just like find the width of a river. I mean, you don't even have to get wet to measure how wide this pond is. So you don't have to go to the other side of the pond. You just, if you set up some triangles here that you know certain angles are the same, then you just measure these three sides here, 1, 2, 3, and you can solve that unknown side through the similar triangles. Okay, one more question. Okay, and it's too bad we're not doing this in class, because usually what I'll do for this example is find in the classroom how tall, how far off the ground maybe the clock is, or the height of how high the ceiling is. And for something like this, you can't use sunlight like you could with the tree or the flagpole. So this would be an indoor or cloudy day question. Okay, so what we're going to use this time is a mirror. Okay, so let's just read the question first, and we'll talk about the mirror. Elizabeth's eyes are 150 centimeters from the floor. Okay, so that is 150 centimeters there. She places a mirror on the floor. That's 18 meters from the climbing wall. So you have a climbing wall here. Okay, and that's what you're going to want to find, is how high is the climbing wall, which is indoors. So she strategically placed along the floor a mirror. So the mirror is right there. Oh, sorry, it says it's above here. So the mirror is where C is on the ground there. she places that mirror, and she backed up um, a distance away from the mirror, so that when she looked at the mirror, she could see in the mirror the top of the climbing wall. Okay, so so the C is the mirror, the A is the top of the climbing wall, D is her eyes. Okay, so all she had to measure was the 18 meters. She knows her eyes are 150 centimeters from the ground, and she knows that she's 120 centimeters away from the mirror, standing from the mirror. Okay, now the property of the mirror, so it's kind of hard to see there, but if you had a mirror on the ground, right, and if you're looking at it from your eyes, if you look down like that, property of a mirror is whatever this angle is here, call it X, is the same angle that basically that your vision kind of bounces off. Okay, so we call this reflection. Okay, so, and that's always going to be true. You just have to make sure the mirror is flat on the ground and it's on the floor, so it is. So we know from that that this corner angle of each of the two triangles is the same, and we also happen to know that, you know, the climbing wall is at a 90-degree angle to the floor, and so is the person. Elizabeth is standing straight up. So right away we can start showing that these are similar triangles, because we know that angle B is equal to angle, that's an F there. That's because they're both 90 degrees. And then these two angles C and angle C, well, they're in two different triangles. They don't have to be the same, but they are in this case because of reflection. So I just put reflect. Okay, and then again we've got two pairs that are the same, so therefore the third pair is the same. So angle A is equal to angle D, and that's just because triangles add to 180. Okay, and then we can make a conclusion. Therefore triangle, and I'll put them in order, alphabetical order, A, B, C, similar to triangle D, because D goes with A, F goes with B, and C goes with C. Okay, so from this, we can do our two pairs of sides that are proportional. So again, let's start, we always want to start on the top left. We want to start with what we're trying to find, and that's, well, that's H, but in terms of the sides, that's AB. Okay, and what does AB go with? AB goes with 1, 2, 1, 2, goes with DF. Okay, now in this triangle here, this side has to be a side that we know the length of. So it has to be BC, because we don't know the length of AC. And then hopefully we know it's the corresponding side for here. So BC goes with FC, and FC we do know. So let's fill this in. We know that AB is X. We know that DF is 150 centimeters. Now look, we've got a problem here. Didn't have it on the previous one. We've got this length is in meters, and these are in centimeters. So that's going to be a problem. If I just put those numbers in here, I'm going to get some weird answer. Okay, so I either have to convert the meters to centimeters, or I have to convert the centimeters to meters. So I don't want the numbers to be huge, so I'm just going to convert. So 120 centimeters is equal to get meters from centimeters, I divide by 100. So that means move the decimal place 2 places to the left. So that's 1.2 meters, and the 150 centimeters will be 1.5 meters. So now when I put my numbers in here, they all have the same units. Okay, so that's one way. That's, you know, if you're not looking, you have to make sure that all the 3 units that you're putting here are the same units. Okay, so DF. So DF is the 150 centimeters, which is 1.5 meters. BC, well, we're going to keep that as 18, right? Because that's meters already. And then FC will be 1.2 meters. Okay, now to get x by itself, we multiply both sides by 1.5. So that's 1.5 times 18 divided by 1.2. And when we do our calculator math, 22.5 is our number, and that's going to be in meters. So therefore, the height of the climbing wall, I'll just say the climbing wall is 22.5 meters tall. Okay? And again, another kind of cool question, like if you can't climb the climbing wall and you want to know how tall it is, you can actually do it with just a little tape measure and a mirror, and you can get the exact answer without even getting to that point. Okay, so there's 3 different techniques, basically all the same strategy. You prove that the 2 triangles involved are similar, and then you use the ratio of the sides to find the missing side that you're looking for. Okay, so there's a few questions here. I certainly don't expect you to do them all, but do enough until you feel confident that you know what's going on. Okay, the answers for these will be attached to the lesson. Okay, so have a great day, guys.